Hi there. Um, this is a video to help people with the idea of the area under curves. So this is an idea that sort of worked out a couple of times in our worksheets, and for many of you, by doing that work on the worksheets, you grasp the concept fine. For some of you, I think are still maybe not 100% sure of the idea, and maybe some need a little bit more help. So here we go. So the basic idea here is that if we have a velocity time curve, we can get all sorts of different information from it. So, for instance, let's take an example of an object that's going maybe 3 meters per second, traveling for, say, 4 seconds. So the graph would look like this. If it's constant velocity, it's a horizontal line. Now, if we look at that graph and we just think about the geometry of the graph, what we have here is some sort of rectangle, some sort of height and width. We know that area is height times width. We can take that same idea and apply it to this particular graph. So if we take the area, which is the height, so it's 3 meters per second, times the width, so the width is going along the bottom there, but it's 4 seconds, and we can try to compute this. So this works out to be 12, and we have to be a bit careful with the units. Almost everybody in class at the first try got the units wrong, so let's just think about the units for a sec. If we have meters per second times a second, most people said that was equal to a meter per second squared, and that's not correct. If that was correct, you would have something like meters per second times 1 over a second. That would be meters per second squared. Okay, but that's not what we're talking about. I think visually, the problem here is that people quite often write this as meters per second times second, and it looks like, well, those two things are multiplying together, so this is meters over second squared. And that's the issue. That's what makes it kind of hard, I think, is the visual appearance of it. If we are really careful in how we write our fractions or units, we could write it like this actually. It's meters per second times a second over 1. Anything over 1 is the same as the initial thing. So that those cancel out and you get a meter. Meter over 1 or meter. So that's what this is. This is the seconds cancel out and we get 12 meters. So in other words, what we're saying is that the area under this curve, this velocity time curve, that's a positive number by the way, is equal to a displacement. Why do I say displacement? Well, if we have a unit meter, I guess we only have two options. It's either a distance or a displacement. That's what the meters are a measurement of. And since we're dealing with velocity, which is a vector, we're going to say that the area is displacement, which is a vector. So that's why we have a positive. You could also actually have a negative displacement, and we'll see that in just a second. So here's an example that I went through in class, and I'm going to use the same one here. So maybe we could number a bunch of tasks that we'd like to do with this velocity time curve. Maybe first thing we'd like to do is say shade area under curve. Yeah. Strictly speaking, we're not looking for the area under a curve. What we really are doing is looking for the area that's bounded or surrounded by the curve and the time at the time axis, the horizontal axis. So this is one area. Here's another area. And there's the third area. So we can call this maybe area 1, area 2, area 3. Okay, next task we could find maybe we'll use black here. Easier to see. Find displacement from 0 to 2 seconds. Just as a reminder, we had this in one of our initial notes. That symbol there. If you put the arrow over top, that's a vector. It's displacement. Without the vector, it's a scalar, It's distance. Okay, so what I'm trying to do is I want to know the displacement from 0 to 2 seconds. Well, from 0 to 2 seconds, that's the area, which is the displacement, which is 2 meters per second times 2 seconds, which is equal to 4 meters, positive 4 meters. Alright, next one. The obvious choice would be find displacement from 2 to 6 seconds. So that's this one here. That's the area is equal to the displacement, which is equal to the height, which is -3. So this is where it's important to keep track of our negative signs. -3 meters per second times 1, 2, 3, 4 seconds. That's -12 meters. I guess we should say that's positive 4 meters. Actually, I'll do it in red. It's -12 meters. And then the last one would be find displacement from 6 to 10 seconds. That's this guy. So from 6 to 10 seconds, there's the area. So that's the displacement. And that's 1 meters per positive 1 meter per second. It's kind of sloppy. Times 1, 2, 3, 4 seconds. That's positive 4 meters. There you have it. We've now analyzed the displacement for each of those kind of time regions. So I guess the next question someone might ask is, well, what's the total displacement? In this case, we just add up the displacements from each time. So this is like, say total displacement is area 1 plus area 2 plus area 3, which is positive 4 meters plus -12 meters plus positive 4 meters. That's equal to -8 meters. Done. That's the total displacement. And finally, the last thing we could, like I kind of said at the beginning, we can find a lot of information from this graph. We can also find the total distance traveled. What is the total distance traveled? So, distance, we are not too concerned about direction, so we don't really care if it's positive or negative. We just want to know what happened. So distance would be one way I'd say it is it's area 1 plus area 2 plus area 3, ignoring negative signs. Now, I don't know if you've covered this yet in grade 11 math. You will for sure be doing it at some point. It's actually called the absolute value. If you don't know what this is yet, you can either ask me for help or ask your math teacher, or not worry about it too much. Essentially what the absolute value means is, again, we don't care if it's positive or negative, we just assume it's like a positive number. So the total distance traveled would be 4 meters plus 12 meters, I'm ignoring all the signs so I don't care if it's negative, plus 4 meters. That gives me an answer of 20 meters traveled. Okay, so that sort of is the summary of finding the area under a curve. So and in this case, from a velocity time curve, the area under a curve is displacement.